So the very first one is if you write down the coefficient matrix, subtract lambda off, take the determinant, then this times this will give you lambda squared minus 16 lambda plus 7 times 9 plus 63. So this is AD minus BC, right? So if you do this times this, you get this, and then minus this times this gives you plus 5. And that one, lambda squared minus 16 lambda plus 68 equals to 0. And this time, let me try to complete the square. It should be lambda minus 8 squared, which is 64, plus 4 equals to 0. So that if you move the 4 to the other side, you get lambda minus 8 squared equals to negative 4. Taking the square root gives you lambda minus 8 equals to plus or minus 2i, because square root of negative gives you i. And that gives you lambda equals to 8 plus minus 2i. Now we learned that we only need to deal with one complex eigenvalue if you have complex case. Okay, so for the complex case, we only need to figure out what happens when lambda is equal to 8 plus 2i. So for that case, this matrix here will become 7 minus 8 plus 2i, and then 5, negative 1, 9 minus 8 plus 2i. And then we're just trying to multiply this with AB to give you 0, 0, right? And once again, we only need to look at the top. We don't care about the bottom one. It will automatically be 0 if the top one is 0. And this one is negative 1 minus 2i times A plus 5 times B equal to 0. And again, the tip is I don't see any common factors, so this is all you can get. But since you have 5 as the coefficient of B, we just let that be A, and all should be good. So we just take that A as 5. So you have negative 1 minus 2i times 5 plus 5b equals to 0. And then the reason you do that is by doing so, you can just easily cancel the 5. And the result is that you end up with b equals to positive 1 plus 2i. And all this calculation says that your eigenvector is 5, 1 plus 2i. Okay. Is that good?
Yep.
All right. Am I right?
Yeah.
How many of you got this? Okay, great. So you guys are giving me confidence. All right. So now we compose them together, we multiply the eigenvector times e to the power of the eigenvalue, 8 plus 2i t. And then we have to figure out what's the real part and the imaginary part from here, right? I'm not going to write all the details out, but this is e to the 8t times e to the I times 2t. And the second part, e to the I times 2t, can be transformed using the Euler identity. And the result would be the following. 5, 1 plus 2i, e to the 8t times the second part will be cosine 2t plus I times sine 2t. Okay? So hopefully you can work this out by using the Euler identity. The Euler identity here is e to the I theta equals to cosine theta plus I sine theta. And I'm saying that e to the I times 2t means replacing this theta by 2t. That's how you get that.
I sine 2 theta?
No, 2t. Yeah. All right. Still, the goal is to figure out what's the real part and the imaginary part. So you have to take this much and multiply to these column vectors. Right? Did I make a mistake?
No, it's just hard to read.
Okay.
Yeah, the orange, yeah.
All right. So you multiply this to the top. That gives you 5 cosine 2t plus I times 5 sine 2t. And the hard part is this one. You really have to FOIL it. But let me first write it like this. 1 plus 2i cosine 2t plus 1 plus 2i times I times sine 2t e to the 8t. And I'm saying that it's really hard to figure out which is the real part and which is the imaginary part because you have I, the one with I times cosine 2t will be the imaginary, whereas 1 times cosine 2t will be a real part, right? So in order to figure out which one is which, you still have to multiply further. So this should be multiplied, which gives you I minus 2i, I minus 2, because I squared is negative 1. So you have to write once again as, let's see, so the top one is still the same, cosine 2t plus I times 5 sine 2t, whereas the bottom one is cosine 2t plus 2i cosine 2t, and then I times 1 times sine 2t, so that's I sine 2t. And I times 2i is negative 2 times sine 2t. And that is all multiplied by e to the 8t. And now you can easily figure out what's the real part and what's the imaginary part. Right? So let's do that. Okay, so the real part of the top is easy. It's just 5 cosine 2t. In the bottom, the ones without i's, you have this one and also this one. So they both should be added to give you the real part, which is cosine 2t minus 2 sine 2t e to the 8t. The imaginary part are the ones attached to I. So 5 sine 2t is attached to the I. And then 2 cosine 2t and sine 2t are both multiplied with I. Remember, for the imaginary part, you don't write the I. You're just writing down what's multiplied to I. So this times I, and then the other one is plus sine 2t times I. So that's your imaginary part. And these are separately solutions of this. Now what?
C1 times the real.
Yes.
Plus
So you take the C1 times the real part and plus C2 times the real part. And that's your general solution. xy is C1 times 5 cosine 2t cosine 2t minus 2 sine 2t e to the 8t plus C2 times 5 sine 2t and then 2 cosine 2t plus sine 2t e to the 8t. But this is an initial value problem, right? So you need to apply this as well. And in order to apply this, you have to rewrite this in the form of x equals to something. So x of t, if you read off the top line, it's 5 times c1 and e to the 8t times cosine 2t. And this one is 5 times c2 e to the 8t times sine 2t. Now yt is much more complicated. This is C1 times e to the at cosine 2t minus 2c1 e to the at sine 2t. I should have factored the e to the at out because I don't want to write this all the time. But it's too late. I'll just write it. 2c2 e to the at cosine 2t plus c2 e to the at sine 2t. Now let's try to plug in t equals to 0 both sides. So on the left side, if you plug in t equals to 0, you get x of 0. What is that? 5. It's given as 5. On the other end, cosine 0 is 1, e to 0 is 1, so you get 5c1. But if you plug in 0 here, sine 0 is 0, so you just get c1 as, if you divide 5 both sides, you get c1 as 1. That was easy. How about this one? You get y of 0, which is negative 2. Cosine 0 is 1, so you get c1. On the other hand, anything that has sine of them, sine 0 is 0, so those go away. And you get plus 2c2. Right? That's cosine 0 is 1, so that's going to be 1. And then plugging in 1 in here gives you that c2. Subtracting 1 both sides, you get negative 3 equals to 2c2. So c2 must be negative 3 over 2. Now, don't stop here. What's the next step? You have to plug them back in to figure out what x and y are explicitly. So you have x of t now equals to 5 e to the at. Let me pull out the e to the at once for all. I don't want to write e to the at so many times. So e to the at times 5 times 1 times cosine 2t. And 5 times c2, but c2 is 3 over 2, so it'll be negative 15 over 2 sine 2t. And then y of t is e to the 8t. And then, let's see, c1 is 1. And, there's another e to the at cosine 2t, right? So these two are like terms, which gives you c1 plus 2c2. But c1 plus 2c2 is negative 2, right? So instead of figuring out what c1 and c2 are individually, you can just say this should be negative 2 cosine 2t. And then for the other one, you need to calculate negative 2c1 and plus c2. So let's try to see what that is. Negative 2c1 plus c2 is negative 2 plus negative 3 over 2. So it's negative 4 over 2, negative 3 over 2, so it's negative 7 over 2. So you got the second answer as negative 7 over 2 sine 2t. Okay? And that's it. So hopefully you're not confused with combining like terms. So I combine these two, this one and this one, to get that one. Maybe I should... this one and this one added together gave you this single thing. And this one and this one added together to give you this single thing. Because they're like terms. Okay? Any questions?